Greetings, everyone. Today we're going to review our Foundations unit. This video is meant to be a review of all of the topics before we take our test. Here are the topics we're looking at. Variables and expressions, meaning symbols to words, words to symbols. Order of operations, PEMDAS. Evaluating expressions, meaning let's simplify down to a single number. The real number system and properties of real numbers. Operations of real numbers, multiplying, adding, subtracting, and dividing positives and negatives. The distributive property, and combining like terms. All right, let's jump right in. We're going to look at examples. The first set is given the words. We're going to write them in letters, numbers, and symbols. So the first thing we want to acknowledge is that less than means subtraction. But remember that L sound? Less than goes last. So 6 less than a number X. So order does matter. The quotient of a number Y and 15. I see this word quotient and that reminds me of division. So I'm going to have a division set up, whether it be a fraction bar, a slash, or a division symbol. And order matters. So the Y has to come before the 15. All of these would be acceptable ways to write this expression. Now let's switch it around. On this one, we want to take the numbers, letters, and symbols, and we want to turn them into a sentence. So to start off, I want to acknowledge that I have a subtraction sign and I have a multiplication sign. Even though it's not there, I could draw a dot so that I remember. So let's turn this into a sentence. I'm going to start off with 7. I'm going to pick the most common words that I see, but you can definitely use different vocabulary. I'm going to say 7 times. You'll have to excuse my writing. I'm writing on my computer. Don't forget the phrase, a number, X. And then for the subtraction sign, most students have been saying that word subtraction. So I'm going to say subtract 1. Let's take a look at this one. The order in which I write this matters. So I only have one operation I'm dealing with. So I'm going to have 2. Most students have been choosing the word divided by. Again, excuse my writing. And when you say divided by, don't forget that phrase, a number Y. So here's the thing. If you're going to forget the phrase a number, just look at the previous problems, because the previous problems are sentences, and that'll remind you about that phrase. All right, the next is simplifying using PEMDAS. So on this one, we want to multiply first. And remember how I like to see that line drawn? Just lets me know what you're doing. What are you looking at? What are you concentrating on? And then the last operation is always going to be easier. In this case, I have multiplying and dividing. So we have to remember that when we have MD, we go left to right. Okay, so watch out for that, because if you solve this a different way, it won't work out. So if I'm going left to right, I have to divide first, then multiply. All right, PEMDAS says parentheses first. So when I'm in the parentheses, I think through PEMDAS. In the parentheses, I have an exponent. I need to take care of that exponent first. Okay. Now I'm still in parentheses, so the next thing I want to do is I want to multiply what's in parentheses. And the last operation, again, should always be the easiest. All right, if I have 2 sets of parentheses, I can take care of them at the same time. So 7 divided by 1, the plus sign falls down. 20 divided by 5 is 4. Don't forget that little squared that comes down with it. Next, I take care of the exponents. Now the parentheses have been taken care of. Remember that 4 squared actually means 4 times 4, which is 16. And then the last operation gets us to a nice clean 23. Now know that in our class, because it's the beginning of the year, this first unit, you should get nice, clean answers. So if you don't, something's up. Next, we're going to work on categorizing in the real number system. So in this case, I have the number 1. All of our answers are real in this class this year. So that's your free answer. You should sit down at a test and go circle real on everything. Okay? Next, you need to decide if it's rational or irrational. Well, it's rational because it's an easy number. I could remember that. Next, integer. Remember my hint or my clue is an I sideways is a number line. Is 1 on a number line? Yep. Whole. I like to say cookies or cars, right? Can I have 1 cookie? Yep. And is it natural for little kids to know 1? Yeah, that's the first number they learn. 1/3. 1/3 is a real number because that's your free answer. Is it rational or irrational? Well, it's rational because look, it's a nice clean fraction. It's nothing crazy about it. Is it on a number line? On a typical number line, no. So if it's not on a number line, it won't be anything below it, right? Think of those those nesting dolls. If it's not an integer, it can't be whole or natural either. Square root of 9, I have to think about this first. Is there a number times itself that gets me to 9? There is. Square root of 9 is actually the number 3. So knowing that, I want to use the number 3 and then categorize. All of our numbers are real. It's definitely rational. It's on a number line. I can have 3 cookies, and it's natural for little kids to know 3. Square root of 2. Is there a number times itself that gets me to 2? There is not. So this is a crazy number. And if you're not sure, use your calculator, plug it in. It'll show you the crazy number that's never ending. Now here's the thing. It's still real. That's your free answer. But this time it's irrational. It's a crazy number. If it's irrational, you're done. Okay? Because if it's a crazy number, it's not going to be on a number line. You can't have that many cookies. And it's not natural for little kids. 0. Here's my free answer. It's real. Definitely rational. 0 makes sense. It's easy to work with. It's in the middle of a number line. Can I have 0 cookies? Yep. And here's where it stops. It is not natural for little kids to know 0. They start at 1 and then they go up. Think of little babies, right? -5. Free answer. It's rational. It's definitely on a number line. But I can't have -5 cookies, so I'm done. I can't be whole or natural. Next, we're going to take a look at real number properties. So remember, this is a matching set when we do these. Once you use an option, then there's no other options to use. So the first thing I'm going to acknowledge is that I have a plus sign. Because I have a plus sign, that means not an option, right? Look at all these that are out. So now I want to take a look at what's left over. And I'm going to say, is it commutative, associative, or identity property? Well, it's not identity, it's associative. Associative meaning who they're associating with changed, but they're all still friends. Now, it's one-to-one matching. If I use the associative property, I'm not going to use it again, so we're going to cross it off the list, right? All right, next I have an addition sign. So I'm going to just, first of all, cross off all the multiplication options. Well, that makes it easier. I only have 2 options. It's not commutative because things aren't flipped around. So my option is the identity property of addition, meaning what can I add and keep my identity? All right, next up I see a multiplication symbol. Okay, so this time I can cross off and ignore the addition options. Am I multiplying by -1? Nope. Am I multiplying by 0? Nope. All right, now we're down to 3 options. And this one is associative property because 5, 6, and 7 are just associating with different numbers today. All right, next I have a multiplication symbol again. That's the first thing I want to recognize, so that's out. I'm not multiplying by 0. That's out. I'm not multiplying by -1. See how quickly it narrows down? And in this case, I have the identity property of multiplication because I'm multiplying by 1 and I'm keeping my identity. The identity stays the same. All right, I'm multiplying again here. So am I multiplying by -1? Nope. 0? Nope. Commutative property, well, look at that. Process of elimination's my friend now, because the only option it can be is the commutative property, which reminds me, oh yeah, that's that flip one, right? See how the numbers flip? We're down to a couple of options. I'm multiplying and I'm multiplying by 0, right? That one should be the easiest one of all. In this case, I'm adding, so by a process of elimination, it has to be commutative property, meaning the numbers flipped around my addition sign. And how nice is that? When you're down to the last option, it should make sense. Am I multiplying by -1? Yep. The next set is dealing with your positives and negatives. So knowing if you're going to use a number line, if you're going to use the rules. In the case of addition, you find the jump. The jump from 2 to 5 is 3, and the bigger number is positive, so +3. But remember, if you want to use a number line, that'll be on the test, and you could show your jumps of 5 and that you'd land at 3. -2 times 5. Okay, numbers first, right? That should be easier. 2 times 5. And then a negative times a positive is always different, so it's going to be different. -10. -2 minus 5. If you choose keep, change, change, keep the first number, change the sign to addition, and change the sign of the second number. So if I'm in the whole $2 and I'm in the whole $5, I'm in the whole $7. You could also use number line. At -2, let's go left 5. I'd arrive at -7. Oh, this one looks weird. I'm subtracting a negative. I'm going to do keep, change, change. Keep, change to addition, change the sign of the second number. Oh, -2 plus 5. We actually did that one already, right? The jump from 2 to 5 is 3, and the bigger, and the bigger number is positive. So +3. Multiplying, take care of the numbers first. Then decide a negative times a negative is a positive. Dividing, divide first. 10 divided by 5. A negative divided by a negative, positive. So again, maybe consider jotting these rules down on your test so you don't forget them, right? Can you memorize maybe this little chart if you need to? Got to come up with some way to help you out. We're multiplying, so deal with the multiplication first, and then a positive times a negative is a negative. 5 times 5, deal with that first. A negative times a negative is a positive. Dividing, divide first. 5 divided by 5, 1. Negative divided by negative, positive. All right, let's move into distribution. So we're going to distribute what's on the outside of parentheses in. So you wouldn't write this down, but let me show you what this means. It means -5 times y, and it means -5 times +5. See how I got that? So if I multiply -5 times y, I've got -5y, and a 5 times 5 is 25, and negative times a positive is a negative. So I create an expression. This will be on almost every homework assignment, test, quiz that we take. When you have just a negative outside, you have to remember that technically there's a 1 there. That's the identity property, meaning what can I multiply by and I keep my identity? A 1. Now the negative becomes my negative 1. Negative 1 times x is negative 1x. Or if you just want to say negative x, that's okay. A negative 1 times a negative 5. Okay, 1 times 5 is 5. Negative times negative, see those two signs? Becomes a positive. So we have our expression. Combining like terms, this tends to go the best, but you just need to figure out a way to stay organized. So if it's colors or lines, I like to underline maybe all my x's first and add them. If you want to use colors, maybe I change colors and underline all my y's and I get 10 y's. Maybe you want to use shapes, like I circle all the z's. 8 z's plus 3 z's is 11 z's. Or maybe you want to do shapes or squiggles or curves under. A 10 plus a 3 is a 13. Okay, so come up with your strategy to stay organized. Now let's combine those two ideas. We're going to distribute and then combine like terms. So I'm going to treat this like two separate problems to begin with. So 5 times x is 5x. Positive 5 times positive 5 is positive 25. All right, I'm going to look at the right side. Positive 4 times 2 is a positive 8x. Positive 4 times positive 4 is positive 16. Now I want to combine. If I have 5x's plus 8x's, I now have 13x's. If I have a positive 25 and a positive 16, that would get me to, what do we got, 25, 35, 41. Let's try one more, but this one has negatives in it, okay? So again, I'm going to think of it like two problems for a minute. First, I want to distribute negative 2 times 4 is negative 8x. Negative 2 times negative 6 is positive 12. That positive is going to be very important. It's going to change things. Let's look at the right side. Hey, look, I got a negative 2 again times positive 3 and a negative 2 times positive 4. All right, I distributed. Now let's combine. I have negative 8x. I'm actually going to use lines for that. Negative 8x and negative 6x. And some of you have been drawing lines like this. That works. If I'm in the whole 8 xylophones and I'm in the whole 6 xylophones, then I'm in the whole 14 xylophones. And then I need to look at my constants. If I have a positive 12 and a negative 8, 12 minus 8 is positive 4. Now see how we created an expression, a numerical sentence, right? All right, so in this video, I recapped every type of problem we have done in this unit and that you can expect to see on the test. Make sure that you check Google Classroom to see what do you have to practice, complete, work on. Check PowerSchool to see what you need to catch up on. Let me know if you need anything, and until next time, have a good one.